Okay guys, welcome back. Um, so let's look at what we did in the last lecture, okay? Quickly. And then we'll do the exam review. We'll practice some of the problems for exam. And then we'll talk about the application of the optical system, or basically optical instrument, okay? So, last time we, really before last time we did the, law of reflection, when we were talking about the mirror and the law of reflection. The important thing is angle of incidence equal to angle of reflection, right? There is also a phenomenon called refraction. This is also a property of the light. And then according to Snell's law, n1 sine theta 1 or theta I, it doesn't matter what you, this notification here, I have like n1 sine theta I equal to n2 sine theta r here. As long as you're constant, this is fine. Last time we wrote ni sine theta I equal to nr sine theta r, okay? So just make sure this part here is for the medium where the light is incident, and this part here is for the medium through which the light is exiting, or okay, so this part is important, right? Or where the refraction is taking place, basically, okay? So, and this r is not reflection, it is for refraction. This theta r is an angle of refraction, not reflection, not like this. So this theta r and this theta are not same, okay? So this theta r and this theta are different. Alright, so that's the important things. Lenses, we also talk about, magnification of lenses, magnification of images, and then also we looked at the thin lens equation. Both the magnification and the thin lens equation are also applicable for mirror. So the magnification is here it's given as y dash by y equal to minus s dash by s. Instead of y dash by y, we just said s dash, right? So last time we wrote m equal to s dash by h, okay? Here I just have it written as a y dash by y, and I didn't want to change it in the, in my Word document. So same thing, they are same. And then that is equal to minus of s dash by s, okay? So s dash was the image of the height, it was the height of the image, it was the height of the object, and then here s dash was image distance, and s was the object distance. And we said s is always positive, right? The object distance is always positive. S dash could be negative depending upon whether we have a real image or virtual image, right? Okay. And then we also have a mirror equation, the thin lens equation, where this equation relates the focal length with the image distance and the object distance. And you see the equation is here, 1 over f equal to 1 over s plus 1 over s dash. Okay, this is a thin lens equation. And we also talk about ray diagrams. You're supposed to work on, practice some of the ray diagrams formed by lenses based on your textbook. So I hope you did that. If you have not done already so, please make sure you go and practice ray diagrams, okay? How to make a ray diagrams from your textbook, okay? That is for a review. Okay, so I'm gonna write down some of these questions here. that we'll practice today, and then I'll let you guys solve it for some time, and then I'll also show you guys or give you guys hint or solve it here. Okay, so let's look at we did one of the problems in the last lecture, so today let's do or maybe rather than practice, I'll say exam review. So remember, the exam is for chapter 15, right? 15, 16, 17 and 18. So we have 4 chapters for exam. I'm gonna just write P for problem, okay? Problem equal to P, okay? So you know when I say P, it means problem. Let's just say problem 1 for today. A tuning fork has a frequency of 440 hertz the string of a violin and this tuning fork when sounded together produce a bit frequency of 1 hertz. Okay, from these two pieces of information alone is it possible to determine the exact frequency of the violin string. Alright guys, so please write down these questions on your notebook. Okay, so we are given a tuning fork that has a frequency of 440 Hz, and there is another string of a violin, and this tuning fork, when sounded together, they produce a bit frequency. Okay, so this is a key information here. Bit frequency of 1 Hz. From these two pieces of information alone, is it possible to determine the exact frequency of the violin string? What do you guys think? Try to work on this for maybe give yourself another 2 minutes or so and try to work on this, okay? Alright guys, so how far did you get? What did you get that? Did you find whether we can determine the exact frequency of a violin string with this information? What did you find? Let us see. Okay, so I'm gonna try to see working out here. So this is the case of the bit frequency, right? So we know, so let's write all the given information here. Here. Let's call F1 equal to frequency of tuning fork, which is equal to 440 Hz. Okay. Let us call F2 as a frequency of a violin string. This is for a violin string. Okay. We don't know what is that.